Welcome to IMUA's Quick Bites, a micro-learning series featuring subject matter experts in the inland marine industry. I'm Eileen Monreale, Education Training Specialist for IMUA. For today's topic, Update on Southern California Wildfires, I'm honored to introduce Dr. Tom Jeffrey, Senior Principal, Geospatial Scientist for Logic. Welcome, Tom.
Well, thank you, Eileen, and thank you again for allowing me the opportunity to talk about wildfires today. Certainly a topic worthy of discussion, kind of in an unconventional time of year for most of the time when we're looking at wildfire activity, we're looking later in the year. But this is, again, one of those examples of wildfire being an all-year hazard. In other words, there are parts of the country that are susceptible not just during the peak of wildfire season, but actually at the off times of the year. And that's part of what I want to talk about, because these fires that we're mentioning today in the Southern California area around Los Angeles, these are fires that have some characteristics that are uncommon. And I don't mean the fires are uncommon. Obviously, Southern California experiences a lot of wildfires over the course of a year. And these are in an area where you have the expectation that wildfires will occur. You just don't have the expectation of January fires. And again, that's another area that I want to provide some background and explanation on. The primary concern here are the large fires, the Palisades fire and the Eaton fire. They've gotten the most attention because of an outbreak that includes at least 8 or 9 or more fires, most of them small. These are the two large ones, and these are the two fires that are causing all of the really concern and damage. And we're looking at numbers, again, the final tally is not in, and it won't be for a little while, but we're looking at 12,000 plus homes potentially destroyed in both of these fires combined. And we don't know what those final numbers really are, but an early estimate indicates that they're both very tragic events. And the other two areas indicated here as fires, Kenneth Fire, Hurst Fire, although they're not labeled, are smaller. They're mostly contained, really did very minimal amounts of damage just because of where they were located and the fact that they were able to be contained relatively early on. And we're going to talk about why the Eaton Fire and Palisades Fire were able to burn as much area as they did. But again, the January fires in California, we've had destructive fires in that area in Southern California in January. It just isn't what you expect because of the weather patterns and the different factors that influence when fires are more likely to occur, when areas are more susceptible. One takeaway from this map that I find interesting is that there's a lot of discussion about the response to the fire and the ability to contain these fires and applying the right resources to these fires. And I'm not here to really talk much about that, but just from my perspective, having done this for a while, is that when we look at where these fires are located, you can see that they are relatively scattered around the Los Angeles area. Now, again, in addition to these, there were another half a dozen or so that occurred that had to be addressed as well. The fact that the Eaton Fire, Palisades Fire grew considerably compared to the others is kind of testament to the fact that all of the other fires were either contained or extinguished relatively early on. They weren't allowed to expand and grow. It just so happened a set of circumstances is responsible for Eaton and Palisades growing like they did. But the fact of the matter is, when you think about the resources allotment for this, the ground crews, the aircraft, where you're actually fighting fires, all of these fires had to be addressed. In other words, you can't just let small ones go because small ones become large ones very quickly. So the difficulty in fighting these fires is really obvious when you see that there are 4 relatively major fires and they're all in different geographic locations scattered around the Los Angeles area, and they all had to be addressed, not just in turn, but at the same time, simultaneously. Again, makes the deployment of resources very difficult. Now, the core of what I would like to talk about today is really 2 things. One, the factors that led up to the fires and the conflagration that occurred within the fire, and then a little more of a deep dive into the distinction of what a conflagration is and what a wildfire is. because it's not that they're unrelated. They truly are. But at the end of the day, we have to consider what type of fire we were dealing with in certain areas associated primarily with the Palisades and Eaton wildfires. So to start this discussion, and I'm not going to spend a long historical diatribe on this, but we have to go back a couple years. And we're looking at the winter of 22-23 and the winter of 23-24. The Los Angeles area and Southern California received about double the amount of precipitation that they normally receive during those periods. And again, we're talking about the winter season, typically where the precipitation, the rainfall comes in Southern California. In both cases, in the 2 years leading up to these events that we are experiencing now, they had very large amount of precipitation. When you have double the normal amount, double the average that you normally receive, you're going to see a lot of changes in the natural environment. All the vegetation that relies on that moisture in the ground is going to expand. It's going to grow. You're going to have an expansion of the existing growth. It's all going to flourish very well. And in dry environments like Southern California, whenever you add rainfall and precipitation, you get more vegetation. And in this case, a lot of the new growth in those two periods was what we call flashy fuels. In other words, in wildfire terms, we're looking at grasses, light shrub growth. These are the things that are easy to ignite and really feed a fire very well under the right conditions. Those are the types of plants that really, really thrived with that excess moisture over the last couple of years. So you've got a lot more vegetation to fuel fires because of the excess in precipitation. Now let's move ahead to the last 9 months of 2024, leading into 2025. All of a sudden, no precipitation. And that is expected. I mean, it's kind of seasonal that it gets dry in the summer in Southern Cal. But the issue here is that they had less than they normally get. It was 0.16 inches over that time period leading up to these fires, which means everything was just critically dry. California had pulled itself out of drought conditions in the early part of 24, late part of 23, and all of a sudden now they've moved back into drought conditions. So it's again drying everything out with that lack of precipitation. 2025 was actually the first 2 weeks of 25, the driest start to the year, to a new year since 1877. Just telling you how that kind of culmination of all that lack of precipitation, and in fact that 2024 summer, hottest summer in the last 130 years. Now you've got heat drying out this vegetation, you have no precipitation, all of that new growth, flashy fuels, grasses, brush, and all of the existing vegetation, very, very dry, very susceptible to any ignition, and makes any fire that occurs very efficient. In other words, when you think of dry wood, dry kindling, all the things that you use when you build a campfire, that's the kind of stuff that all of the vegetation, that's the condition all of this vegetation was in. And what that means is that you have part of the recipe in place. All you need is an ignition. But to go a little bit further into the conditions, we also have to talk about the wind, because that was one of the primary things that's come up in the last couple of weeks when these fires are occurring. Southern California experiences seasonal winds. They're called the Santa Ana winds, and most people have heard about them. They come from about October through April, and it's the time period where you have winds that's blowing, instead of onshore from the ocean, the direction reverses. They're blowing from the land offshore. So it's very dry wind coming from the desert. Doesn't have any moisture with it. It's not going to bring any rainfall necessarily. But what it's going to do is it's going to, again, the wind helps to dry out the vegetation, but it also fans the flames. And it makes fires that do start into very quick moving, almost always more intense, produces more heat, the kind of fires that are going to do a lot of destruction, a lot of damage. And those always occur October to April. And so the question may be, why don't we see this happening every year? Why don't we have these kind of fires every year if that's where it's going to be really windy and dry? Well, the answer to that is from about November, December through, again, April, you typically have the wet part of the year in Southern California, where the precipitation, most of the precipitation that occurs annually is going to fall during that period of months. And fortunately, historically, that period of precipitation, greatest precipitation in the area, is going to occur at the exact same time as those winds ramp up. And if you have wet fuels, wet vegetation, doesn't matter how windy it is, it's really hard to ignite. And if it does, it's not going to burn very effectively. So this year we saw the conditions, again, that we normally expect. It's going to be dry, there's going to be fuel, but we saw wind occur and move these fires because there was no precipitation. And that should be happening now. And it should have happened a month ago, started a month or more ago. And so now we have, and again, this is kind of a cliche, but you have to call it the perfect storm. It is all of the things that are going to make a fire burn very quickly, very hot, and move very fast. And they're all happening at the same time. So those are kind of the lead up factors. Now the photos, the pictures, that actually satellite images that I'm showing now are part of the Palisades fire. Just picked one area within, again, the urban, the dense development. And there, unfortunately, is so much coverage that you could have picked just about any area in Palisades and shown something somewhat similar, very similar. But the situation is, in terms of before and after, you notice that it's almost 100% destruction. There really isn't anything left within the scope of this image, and that extends for miles throughout the Palisades fire and the Eaton fire, both of them. And what you see here is a wildfire, and by definition, a wildfire is something that starts in natural vegetation, and then it migrates either towards houses or towards an urban environment. However, the destruction you see in this image is not what I would classify, and others in the scientific community would classify, as necessarily the result of direct wildfire ignitions. These homes were almost certainly not ignited from vegetation that was burning outside of the urban environment. You can see that there are some trees, and there's obviously people have lawns, some decorative shrubs. Those are not necessarily the ignition sources for these structures. Almost certainly, most of these, if not all of them, are going to be ignited by other burning structures. And that's the distinction between a conflagration and a wildfire ignition. Now, the fire started outside of an urban area. Could have been any errant spark. Who knows? It could be arson, could be accidental. Believe me, they are looking into this. The first homes that were ignited because vegetation was burning nearby, and either the flames from the vegetation, embers from the vegetation, maybe even just radiant heat from the vegetation ignited those first structures. It wasn't until that fire moved close to the edge of the urban environment, that first row of homes on at the outside of a subdivision, when those ignite, the transition begins. It transitions from having vegetation cause the ignition of those edge homes to now those edge homes become fuel themselves. And as the wind, in this case, extremely strong winds, are pushing those flames and pushing that fire into and towards the more dense parts of the urban development, then that fire begins to go from house to house, structure to structure. And what that means is it's going to be even more intense than if it were to occur in natural vegetation. And it's going to ignite more structures at one time. I would hesitate to say that in areas like this, there were likely not just 5 or 10 or 20 homes that were burning at the exact same time. You probably had literally hundreds of homes that were on fire in the Palisades area as the fire was moving, into and through the built dense urban environment. You had so many structures burning simultaneously that, again, it wasn't just a few scattered at the edge of the development. Really was the heart of the community that was burning in this case. So now you have a situation where, how do you evaluate these fires? Well, a wildfire we evaluate because of where the vegetation is and whether that vegetation is in a condition that will burn very well. If that vegetation will lead to a house starting on fire. In other words, how the vegetation burns, and believe me, All vegetation burns a little bit differently. Grass burns different than brush, which burns different than forest, etc. So that's where wildfire science really plays a role, is understanding how a fire transitions from a vegetation that's burning onto a structure. This is a little bit different type of analysis. Here we have to look at how structures burn and then how structures transmit fire to adjacent structures. Part of that problem is the fact that when I mentioned the wind before, you can't remove the wind from this, because when you think of a fire, even if it's a lit match, without wind, those flames are vertical. In other words, the flames just go up by nature, by physics. That's how fire burns. When you apply 20-mile-an-hour winds, 30-mile-an-hour winds, now those flames start to bend over. And in the case of this fire, these fires, the Eaton and the Palisades, we were looking at sustained 30 to 40-mile-an-hour winds. We were looking at wind gusts that were in the 50 to 70 range, with some exceeding 80, 90, and even 100 miles per hour. So we're looking at, in some cases, hurricane force gust winds that were now, when you think of how does that affect a flame, first of all, it enhances it. It feeds it full of oxygen. It's going to burn very efficiently, but it's also going to burn horizontally. So every house that starts on fire is going to have flames that reach over to the neighboring houses. And that's really what the problem was here. In both of these very disastrous fires, you're looking at conflagrations, turning these fires into something that would have been horrific on its own, even if it was just a vegetation fire that started to burn the edges of the developments. Here it went right through the development because wind turned this into a conflagration, along with the other factors. And cars, homes, boats, anything that is in the yard is now a fuel source. And again, a little bit different way of looking at how fire moves through an area. And to call it the entirety of the damage related to wildfire, yes, as a original ignition, of course. But once it hits this built environment, we have to start thinking of this as a different type of fire than just a wildfire. It was a wildfire sourced urban conflagration is really what it was. So that's the long story. The short story is, what is the outlook? Well, there is some good news on that front. Just from last night to this morning, there is more containment on these two large fires. And they're right now the two ones that are the only ones that really are effectively burning. We see, and again, I'm not a meteorologist, but we do know that, again, the winds have died down somewhat. Late yesterday, they started to lay down. That is supposed to continue through maybe the weekend, but then ramp back up next week. So there will be winds returning. Again, Santa Ana's, the traditional seasonal winds that occur, they will be increasing again next week in wind speed. Red flag warnings, fortunately, were lifted for the city of LA yesterday on the 16th. We don't know what's going to come, but again, all of the other conditions, there is no precipitation in the forecast to speak of. So these dry conditions will persist. The thing that's going to shut this off and really turn it around this year at this time is going to be precipitation. If we can get some seasonal rains to occur, that's going to make sure that we just don't get these kinds of ignitions that are going to light up these flashy fuels and all of the dry fuels that are out there. The final thing that I guess I would add to the discussion, which is very incomplete, it's really just on the horizon right now, but there is some preliminary discussion, is about rebuilding these communities. And we know that there are probably, between the two fires, somewhere in the neighborhood of 12,000 plus structures that are destroyed. And that number could increase, unfortunately, pretty dramatically when they start to do a better assessment, when they're actually able to access these areas, do a better assessment. But we're looking at a lot of damage. The Camp Fire in 2018 was the most destructive in California history. This could certainly, I don't think it will overtake it, but it will approach it. It will get, it will be bad enough. And again, it's not important to rank these. It's really important to understand what to take from that. And one of those things that I'm going to just mention here briefly is that the rebuild of these areas is going to take a long time. It's a very difficult, complex process to have the materials, the resources, the workforce that can go in and start to clean up first, and then replace these structures. And in terms of some of the early damage estimates that I've seen from CoreLogic is that we are looking at very likely the most costly wildfire event that we've ever had in this country. And that would be, again, that would be difficult to replace quickly. So it's going to take a while. So with that, I guess that's, for now, that's what we know. That's, you know, in terms of a wildfire science explanation, I've tried to provide you with some background information, hopefully some better understanding of what type of fires these were. And again, conflagrations are not unprecedented. The Camp Fire was conflagration. The fire in Santa Rosa, I think it was 2017, the Tubbs Fire, that also had a conflagration component. And again, losses of thousands of structures because of those fires. But I think the understanding that the takeaway that I would hope that you would have would be that conflagrations can be a part of wildfires, but they're not associated with every wildfire. Most wildfires do not end and result in conflagrations. So with that, I would just like to wrap up that we do have other information, more additional information available through CoreLogic. We are following these fires as we do with every one of these events that occurs during the course of the year. And we like to provide enough information that hopefully people can get an understanding of what is going on and our perspective on these events. And also we have, through IMUA, I will let Eileen talk about this.
Excellent. Really, thank you so much, Tom. We really appreciate your preparing and sharing your knowledge on these devastating fires with important and timely information. Urban conflagration versus wildfire is something that was very interesting, and I'm sure we all will look into that. It will certainly shape and affect the insurance industry, and there's so much more to be learned. Certainly our thoughts for strength, peace, and hope for those affected by the fires are most prevalent in our minds. If our viewers are interested in further inland marine insurance education, please use this QR code here to visit the IMUA Learning Portal that has over 150 hours of on-demand education that's complimentary for IMUA members. Also complimentary for IMUA members is an upcoming webinar with Tom Jeffrey on April 1st, Navigating and Mitigating Wildfire in the U.S. Registration will open soon, so keep your eyes on your IMUA calendars. And if our viewers are interested in any information, they can reach out to me at any time. But until next time, I'm Eileen Monreale with IMUA Quick Bites.